This is Mr. Beck Does Your Homework, AP Physics, Homework 6.3, questions 11 and 12. A 4-kilogram object moving with a speed of 9.8 meters per second to the right collides with a 16-kilogram object moving with a velocity of 9 meters per second in a direction 24 degrees from the initial direction of motion of the 4-kilogram object, in other words, like the picture. What is the speed of the two objects after the collision if they remain stuck together? So I've got some momentum here, and these are going to go off in some direction up here, stuck together. Well, I know that this one is going to have some momentum, so that's my momentum total. So let me draw that a little bit bigger. This momentum total is going to be made up of some x momentum and some y momentum. Where does the x momentum come from? Well, this one certainly has some horizontal momentum, so if I did my mv there, I would definitely get some x momentum. But this one is up at an angle, so if I can figure out this total momentum for this object, the momentum of the second object, then I know it's got some x and some y momentum. Its x momentum is going to be part of this x momentum. So now let's look at the 16-kilogram object. So here's my 16-kilogram object. It's moving up at some angle. I know I went a little odd on that. But it's going to have some momentum total, and that momentum is going to be some px and some py. The other object is my 4-kilogram object, and it's moving straight over, so it's all going to be px. So let's see what this one is. This is 16 kilograms moving at 9 meters per second, so this momentum is 16 times 9. This one is going to be whatever 16 times 9 is, times the sine of theta. And they give you theta. Well, if that's 24, this is also 24. So that theta is going to be the same as this. This one is going to be the momentum times the cosine of theta. So it would be 16 times 9 times the cosine of 24 will give me my momentum in the x direction. This one has a momentum in the x direction, and this one is just going to be my mass times my velocity, which is going to be my 4 kilograms times my velocity of 9.8 meters per second. And that will give me my momentum in the x direction for this one. It doesn't have any y momentum. Now this momentum in the x direction is going to be these two added together. So this plus this is going to give me my momentum here. So these two are going to give me that momentum. My momentum in the y direction is simply going to come from here. And that's going to be my momentum in the y direction. So now that I know my total momentum in the x direction, made up of these two, and my total momentum of y direction made up of just this one, now I can do a squared plus b squared equals c squared to Pythagoras and get my total momentum, but I want the speed. So I can do, with this one, I can do px squared plus py squared, square root that equals p total. And then when I got that p total, if I divide by the combined mass, for me it's 16 plus 4, that is going to equal the velocity, because p equals mv, there's my mass, there's my velocity. That'll give me the velocity for this one, the speed of the two objects after they remain stuck together. The second one says, what is the change in direction experienced by the lighter of the two objects? Well, the lighter of the two objects was moving to the right, and now it's moving up here. So really, I'm looking for this angle theta. I can do that with an inverse sine with these two, an inverse cosine with these two, or an inverse tangent with these two. And I will leave that to you.